Web Assign 8, Question 1, Part D. In this part, we're asked to consider what happens when silver nitrate combines with sodium phosphate. We'll start with the balanced molecular equation. As always, when predicting products, you're looking for novel combinations of ions. So what we don't see on the product side, or what we haven't seen on the reactant side, which can appear on the product side, would be silver ion paired with phosphate. And I know to put a subscript 3 for the silver, because silver is one of those transition metals that has a stable charge. It's always +1. Phosphate ion, as you recall, is a polyatomic ion that has a -3 charge. So in order to make those charges balance, you need 3 silver ions paired with 1 phosphate ion. The other novel combination of ions would be sodium paired with nitrate. Each of those have a magnitude 1 charge, so a 1+ for sodium and a 1- for the nitrate. When considering states of matter, as always, the reactants must be aqueous, otherwise they wouldn't mix together. So you can just put an AQ without needing to consider solubility rules for the reactants. It's the products that we need to consider. And Rule 6 of the solubility rules would have us classify phosphate salts as not soluble, that is, put an S for solid. The other product, sodium nitrate, is caught by 2 rules. Rule 1 states that nitrate salts are soluble, and Rule 2 states that group 1 metal salts are soluble. In that case, both of the rules reinforce each other. If there were ever a difference between what solubility rules declare about a compound, the solubility rule that is ranked higher trumps the lower ranked one. Okay, we almost have the balanced molecular equation complete. We just need to add a coefficient 3 in front of sodium nitrate to make the atoms balance. We also need a coefficient 3 in front of the silver nitrate. Now let's move on to the complete ionic equation. As always, we break apart salts which are aqueous. So anything that is a strong electrolyte and aqueous gets broken apart. Since every species in this equation is an ionic compound or a salt, we'll break it apart. So starting with sodium nitrate, or silver nitrate rather, we have 3 silver ions and 3 nitrate ions. With the sodium phosphate, 3 sodium ions and 1 phosphate ion. That completes the reactant side of the equation. You might wonder, why did you come up with coefficients 3 for the silver, 3 for the nitrate, 3 for the sodium, but only a 1 for the phosphate? Well, the coefficient 3 that we wrote in front of silver nitrate carries over to both the silver ions and the nitrate ions, whereas in the case of sodium ion in sodium phosphate, that subscript 3 is the only thing, or only applies to the sodium ion and not to the phosphate. Now to the products. The solid stays intact. Silver phosphate, and I'm going to put a subscript S after it to make sure we keep that in mind, does not break apart because it is not aqueous. The other species, I'm not going to bother writing an AQ after because it gets a little tedious. The other product, sodium nitrate, does break apart. It's aqueous. And as with everything else here, it's a strong electrolyte. We've finished the complete ionic equation. Now, where there's a perfect match of the ion formula and charge on both sides of the equation, we can cross out and not write in the net ionic equation. So I see 3 nitrate ions that can cross out with each other and 3 sodium ions that can cross out with each other. What's left after we've crossed everything out? We have 3 silver ions and 1 phosphate ion, which pair up to form silver phosphate. When writing this equation into the web-assigned boxes, remember the coefficients go in the small box that precedes the formula, and when you have a coefficient 1, you have to actually put a coefficient 1 in the box. Otherwise, WebAssign won't accept it.